Alright, good morning everybody. At least it's morning when I recorded this. I don't know if when I will get this uploaded. But we'll just pretend like it's morning. It's morning somewhere, right? So this is obviously a Soyuz. I made this as accurate as I possibly could in Kerbal Space Program using the mods that I had. The mod I'm using is really awesome. It's got some really good tanks on the side, and it really does a good job at simulating this valve here, which is what we're mostly going to be talking about today. So as you probably know if you're watching this video, there was a recent Soyuz failure of the booster during launch, and we're not, even though the investigation is still ongoing and we're not 1000% sure whether they know what happened, they're pretty sure they know what happened. Now, I'm just going to go over a few design choices on this Soyuz that's a little bit different than regular Soyuz, just pointing them out. Down here, obviously, we have extra burner engines. Normally, they would only have 4 per engine, or 4 in the middle core and then 2 per engine. That's because these core engines here don't gimbal, but these small ones on the sides do. The normal Soyuz doesn't have all of these extra ones. There's quite a few extra ones here. That's because up here at the very top, this fairing is ridiculously heavy. So, and we'll get to that in a minute. We're working from the bottom up. So, extra burner engines down here. They don't do anything really as far as thrust. They just give me more control authority over it trying to pitch over and die. I will upload a second video of all the bloopers, and you'll see why I added these. So as we move up the rocket, of course we got our decouplers here, and on the real Soyuz, the decoupler is down here, and then up here it's attached by a ball joint. Kerbal Space Program doesn't quite do that, so normally there'd be one explosive charge here, and then hinged by a ball joint up here, and during booster separation, this explodes basically. And the force of the engine, as you can see, these engines are straight up and down. So if you draw a line straight through this, it actually doesn't go over the top of the rocket, the booster. That's there for a reason. As this explodes, the force of this creates torque because it's going up through the side here. That torque pushes the booster away from the core stage and hinges up on this ball joint, and after it gets to a certain degree out, because these are still burning at time of separation, then a valve at the top is opened which releases all of the extra liquid oxygen, and that pushes the top of this booster up out of that ball joint and away from the rocket, creating the Korotov cross. It's a really awesome thing to see, especially from this angle when you're looking down on the rocket. It's really cool. There's awesome videos on YouTube. Just Google Korotov cross. So moving up, so we got the core stage, we got the 4 strap-on boosters, we got this lattice structure because the Soyuz, if you may not know, or you probably do if you're watching this video, if you don't, just a quick review. This lattice structure here is because these engines at the second stage start firing before the core stage is done. It's called the hot staging. And then they release. Again, Kerbal Space Program doesn't really tech this very well. When I launch this and we don't have a booster failure, it will overheat this part and explode before I can stage it. So it's not perfect, but we did our best. And you may be able to put a heat shield here if you wanted to. I'm not sure. I haven't tried that yet, but here we are. So use a hot staging. So these second stage engines will burn before the core falls away. And then up here, now this is not a standard Kerbal Space Program fairing, as you can tell, and there's a reason for that. So the Soyuz has 2 different abort stages, if you can think of them that way. This whole assembly, the launch escape tower, which is not the Soyuz launch escape tower, but it works, is there, and then this is called the shroud, and it covers the Soyuz capsule, which is inside of here. It's a really good looking Soyuz capsule. We've got everything we need to in here. It's great. We've got the solar panels and everything in here. It's awesome. So the problem with Kerbal Space Program fairings is they're not really designed to do anything, and this shroud has to do something really important. That really important thing that it has to do is it's part of the launch escape system. So one thing that's not here is there would normally be 4 grid fins on this shroud. They're collapsed, and they normally stay collapsed unless there's an abort. So the reason why you have the launch escape tower and the shroud abort system is, I'm sorry, if there's a failure of the booster on the ground, so the booster explodes during fueling or something, this needs to be able to get the capsule up high enough, has time to deploy the parachutes. So this would fire if it's on the ground or anywhere before 2 minutes of launch. This would fire, pulling the capsule, only the orbital module and the descent module, leaving the service module attached to the rocket, away, and then after this gets done firing, then the shroud engines would fire to get it farther away, or in this case farther up, so there's enough room for the parachutes to fully deploy before they crater into the ground. After about 2 minutes into flight, the vehicle is high enough that they don't need this extra kick in order to get high enough to deploy the parachutes. So this is jettisoned, and the shroud stays active. So then if there's a failure in the booster or the second stage, the shroud can fire its motors and pull away the orbital and the descent module, leaving the service module and everything else behind, pulling it away for safety, and then the descent module falls out. They follow a ballistic trajectory back to the ground, and everybody's happy. This is what happened during the failure. The launch escape tower had already jettisoned when one of these boosters, in this case this one, you can see that one of these boosters are not alike. I hit some motors in there in order to simulate the failure, because of course in Kerbal Space Program everything always works every time. So what's going to happen during our failure is this decoupler's force is only set to 10%, and in fact I'm going to take it down just a little bit more. These are 100%. Oh, these are not. Interesting. Those should be higher. Hang on. I wonder. Oh no! I wonder if it won't let us do asymmetric ejection forces on these. I apologize for that noise. That was probably absolutely horrible in your ear. Okay, well, it still works. So it's alright. We'll take it back to 10. Okay, so what happened during this failure was this explosive charge went off, hinged the booster out, supposed to. This valve did not open, causing the aerodynamic forces and the thrust forces from the core stage to have this booster swing back down around, crashing into the core stage, rupturing either the core stage engine or this booster engine, or both, most likely both, triggered an abort in the computer system. The escape tower had already jettisoned. It fired the shroud, pulling the orbital and the descent module, leaving the service module and everything else behind, and then of course the astronauts and cosmonaut returned safely. Now this Soyuz only had 2 crew because the Roscosmos, the Russian space agency, has decided to scale back their investment in the International Space Station, and so it was only launching with 2 crew, 1 American and 1 Russian. Now you can see inside the shroud here we have all of these engines. These are our shroud abort engines. And we also have some burner engines in here for additional attitude control, because this thing is so top heavy, because this is not your typical Kerbal Space Program shroud slash payload fairing. So let's see if we can do this right the first time. We're gonna go for a launch. Alright, so we're going to simulate this as best as we can to a real Soyuz launch. As you can see, we've got our 2 astronauts here inside the capsule. There's nobody over. Oh, okay. Well, this is a design problem. Normally you would launch with 3, but I promise you there's only 2 in there. Alright, so we're going to turn on all of our things, and we're going to start the staging process. Now the Soyuz takes about 15 to 17 seconds. It starts taking its engines up like this, and it slowly throttles up to 100%, and it finally takes off. Let's see what you do. Now, I'm not going to be doing a perfect gravity turn. We know we're not getting into orbit, but this thing is really hard to control. So, I do apologize. This is not going to be like the best flight or anything like that. Lots of criticism to go into how we fly this thing. But here I can say basically, see, here we go, kind of losing it. We're losing it. And this is not going to work. Oh, well, maybe. We can save it. Okay, well, we'll just go from here. Of course, these guys did land, so there goes the launch escape tower. And here we go with the have our failure. This is a horrible rendition of what occurred. But you can see how the shroud pulled that capsule away, leaving everything to blow up, and then we'll do this to get this out. Now, the parachute wouldn't have deployed exactly at this point. We're just not quite high enough here in this simulation. Let's go ahead and try this again. We'll revert to launch. We're going to do this one more time. Try to get this a little bit better. We're going to do the launch process a little bit faster. Now, this is not professional quality production, obviously. This is done in a rush because I'm busy. I haven't been uploading a lot of videos lately, but I wanted to get this out because I think it's cool, and I want to make sure that if you're looking up information about the Soyuz launch, there's a lot of different things out there right now, and I wanted you guys to have at least something to fall back on, a little bit of an explanation. And I might not have all my facts 100% right. They're still doing the investigation. We'll see how the investigation turns out. Okay, so here we go. Launch escape power jettison. Booster cutoff and separation. See that's hitting into that. We can hit our abort. Well, we didn't lose that first stage there. And it wouldn't have tumbled like this either. It's a much more controlled, but this shroud is so heavy. So then we're going to just continue up on our ballistic trajectory so we don't have any traction, anything going on as far as reaction control wheels or anything. And then we're going to jettison out just the descent module. And again, in the real one, the parachute would not have deployed at this time. They would have fallen back through. They did actually experience weightlessness for a little bit before coming back down. So here we go. All the pieces raining down around us. Now, when that booster hit back into the core stage, it normally would have exploded. And I do have videos of it doing that, but I just don't have it here. So I hope you enjoyed the video. Any questions, go ahead and post them down in the comments, and I hope you enjoy.